Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 18 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 717. 1-bit and 2-bit characters. So in this problem we have two special characters. The first character can be represented by 1 bit. The second character can be represented by 2 bits, 10 or 11, right? So these are the two special characters we have, right? We have given a binary array bits that ends with a 0. We have to return true if the last character must be a 1-bit character. Okay, so let's understand this problem statement with an example here. Okay, so here if you notice, right, so if we have just a 1-bit character, then it will be 0 only, right? Then it will be 0 only. But if we are using this second character, right, so if you see this is always starting with 1, right? Always starting with 1, right? It can be 1 0 or 1 1, right? So here, see, this is 1, so that means this is nothing but a second character. We are using second character, right? So that simply means 1 0 overall, right? So when I am here, when my eye is here, I see 1, so I simply say that my next index is also along with this one only, right? That simply means I am using the second character, right, which is represented by 1 0 or 1 1, right? So next time my eye is going to jump to this position, right? So now when my eye is here, so I see 0, right, which is nothing but the first character, right? So we have to return true if the last character must be a 1-bit character, right? So this is nothing but just a 1-bit character, right? Clear? So that is why we are returning true. That's it. See here, 1, so that simply means if we have 1, so then here maybe 0 or 1, we don't need to check that, right? But if it is 1, then my eye is directly going to make a jump to this, right? Again here it is 1, then again my eye is going to jump here, so I goes out of bound, right? I is not at the last this index. Okay, this index I is not at this particular index, right? So in this case, I'm going to return false, right? Because here first we have 1 1, then we have 1 0. That's it. Here we have 1 0 and then 0, right? So this is nothing but a 1-bit character. But here there is no 1-bit character, right, in the end, right? This is nothing but a 2-bit character only. That's it. Same way here, if you take this 1 1 0, right? If you take this example, so 1 I here, so that simply means if you have 1, so definitely we have 1 0 1 1, so definitely we are using the second character, right, which is represented by 2 bits, right? So my eye is going to make a jump to this position, I, right? Now in the end, if you see, this is only left out part, right, in the end. So here my eye is at nothing but the total length of this, let's say n minus 1, so my eye is at n minus 1 index. So in this case I am just going to return true. Here my I is not at n minus 1 index, right? I is out of bound, right? So I am returning false. Here my I is at last index, that is nothing but n minus 1, so I am returning true here. That's it. Okay, and here these are the bits dot length from 1 to 1000. Okay, these are the constants, and bits of I values either 0 or 1, right? So very easy problem statement right now, because the first character can be represented by just 1 bit, and if we are using second character, then it is represented by 2 bits, right? And 1 0 or 1 1, and we are only using these two special characters only, right? So if you see this, so here this is always starting with 1, so if we have 1, so definitely next will be 0 or 1 only, so we can skip this. Definitely it means that it is nothing but a 2-bit character. Then next time jump to this one, right? So here also we are going to check if it is a 0 only, then yeah, then it is 1 bit. But if it is 1, then again we have to take a pair, right? And then next jump to here, like this. Okay, so let's write the code. Very simple, nothing complex, on very few lines of code as well. So int I is equal to 0, and here you have to run one while loop, and here while I is less than, so here I'm going to write bits dot length minus 1, right? So I am stopping just before this, right? So until here only I have to iterate I, right? If my I reaches here, stop it now, because I will just check where my I is in the end. If it is at the n-1 index, return true. If it is out of mode, then return false, right? But we have to check until here only, right? Okay, so this is what I'm doing. And how my I is making the jumps. So this is my current I, right? So in this, I is equal to I plus, so I will check the value of bits, right? Bits of I. So if it is 0, then the normal jump, right? Next, plus 1. But if my bits of I value is 1, then 1 plus 1 2, right? So if bits of I value is 1, then I'm making the jump of 2, right? So here, let's suppose initially your I is at here, if I just give the indexing 0 1 2, initially your I is at 0, right? So now if you notice, this is 1. So if this is 1, so 0 plus, then you are doing here bits of I value is 1 plus 1. So you are going to get 0 plus 2. So this is the new position, right? New index of I, right? 0 plus 2, that is nothing but 2. Same way here, if you are here 0 0 1, right? If you are here, then next time I is going to move here only, right? 0 plus 0 plus 1, that is nothing but 1. So I is moving to this index, right? So this is how I'm trying this logic. Okay, I'm writing this logic. That's it. And here in the end, we have to just return true if my I is equal to bits dot length minus 1. That's it. Let's run the code. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be O of n. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.